Hey, DT.
There we go. Hi, Len. How are you?
Doing good. How are you?
Good. Super excited for your workshop. It's going to be awesome.
Thank you. Excited too. Let me add the link. For everyone who's joining right now, if you haven't already, you can make an account here. It's really easy and it's free, so it'll be easier to make an account first so that we can get started in a bit. So I'll wait a few more minutes for more people to join. So, yeah. Tinkercad's pretty cool. It's fun to do some 3D drawings and make some circuits.
I think we can wait until about, let's see, maybe like 3:33, and then we can get started. How does that sound?
All right, sounds good. Yeah.
Because we have a ton of people filtering in right now, which is awesome. But yeah, like I said in the chat, Tinkercad is amazing. It's free. You can do so much stuff with it. Yeah, definitely a great thing to check out on your own time, even outside of this hackathon. Tons of stuff you could do with Tinkercad.
Yeah, for sure. And this workshop's probably only about 30 minutes, but we won't be able to cover every single thing that Tinkercad has to offer. So definitely check out all the other features in Tinkercad when you have time, or even after this workshop. Yeah.
I think it's 3:33. I think we can go ahead and get started if you'd like, Lan.
Okay, cool. Let me share my screen. Okay, cool. Is this the right screen I should be sharing, or?
I believe you're sharing the hop-in screen. I can see my face, my beautiful face, with the Band-Aid on my forehead. You know how it is.
Let me share this tab instead. Okay, is this better?
Oh, yeah, it looks like Autodesk.
So
the video should be maximized right now. If you're in the audience, can you see that this window is bigger than our faces? Because that's what we want.
Yeah. If not, I think you can double click on the screen that I'm sharing, and then it should become full screen.
Mm-hmm. Yeah.
And I don't think I'll be able to check the comments. So
I was muted. I'll be able to check the comments for you. So you do your thing, and I'll be in the comments.
Okay, all right. Thank you, Aditi. Okay, so we'll get started. Hi, everyone. Welcome to the Arduino Tinkercad workshop for beginners. So after you make your login screen, or after you log in, this should be the screen that you guys see first. And we're actually going to be working with Arduino today. So on the left side, we want to go to the Circuits tab. And this is where we can start building our circuits. So you want to make a new circuit. Yeah. By the way, if I'm going too fast or you have any questions, feel free to let me know and I'll try and slow down a bit. Yeah. And so this is our workspace for where you can build your circuits. And the first component that we want to pull out is our Arduino. And you can scroll down on this right side where all the components available on Tinkercad are. And we scroll down and you can see the Arduino Uno. And we'll click on that and drag it out here. Yeah. And so your Arduino is a microcontroller, which is essentially a circuit board that you can write code for, and it'll execute. It'll either take in commands or execute commands depending on the code that you write. And the next component that we're going to pull out is our breadboard. And so we want to include this breadboard so that it's easy to organize all of our electrical components, as well as the wiring that we're going to be using later when we're building our circuit. Oh, and for this first part of the workshop, we're going to be building a circuit with an LED, and you can write code so that it causes the LED to blink. And so for this circuit, we'll definitely need the LED itself, and you go back to the top and you can pull it out. So I'll leave it out here first and talk a little bit more about how the LED works. So you can see that the LED has two legs, and one of them is crooked, and that's going to be your anode, and the straight leg is your cathode. And so the reason that there are two different legs is because the LED has polarity, so it'll only take in voltage and current from one direction and output the rest in the other direction. If you do it in reverse, there will be some problems, so the LED might not work properly. And we'll bring this LED back into our breadboard, and we can put it right here. And so a little bit of background about the breadboard. You can see when you hover over these pins, there's like a green highlight. And so that's letting you know that all of the pins, all the components that you put in these pins will be connected to each other without having to put extra wires to connect them. So with this LED, we actually want to have them in two separate rows so that they're not, well, in here it's, in this screen, it's columns, but they're basically, the pins are connected in the same row. And we want them separately because we don't want to accidentally short circuit the LED itself. So we'll keep it in separate rows. And then we'll bring out the resistor, and we can put it right here. So again, going back to what I said previously about putting legs of the same electrical component in the same row, you're going to end up shorting your circuit. So we want to make sure that we don't keep the legs of the resistor in the same row. And so how we can change the orientation is going up to the top left corner, and we can actually rotate it. So we'll rotate it and make it horizontally. And to make sure that the resistor and the LED are connected to each other, we'll want to make sure that one of the legs from the resistor will be in the same column or row as the leg of the LED. And so now you can see when you hover over it, you can notice that now you can check that one leg from the LED is connected to the same row as the one leg of the resistor. And one more note about the resistor is that there is actually no polarity in the resistor. The resistor is just there to help limit the amount of current or voltage that is going through. And so polarity doesn't matter for this case. And the reason that we also have a resistor is because for some LEDs, they have what's called a forward voltage. And your forward voltage is the amount of voltage that can operate safely on the LED. And so that's about 2 volts. The LED forward voltage is about 2 volts. But the Arduino itself actually outputs about 3.3 to 5 volts, which is too high for the LED to work properly. So that's why we have a resistor to make sure that we're limiting the amount of voltage that can come through, and so that when the current goes through the LED, it doesn't burn up. So now that we have the 2 main components in, we can actually start plugging it into the Arduino itself. And so with this resistor, so we'll want to connect the resistor first to one of the pins on the Arduino. And so what we can do is click on one of the pinholes and drag it out. We'll click here, and then we can bend that wire, and we'll plug it into, let's pick pin 12. So we'll connect it to pin 12. And so with pin 12, this is where we'll see it in the code later when we're programming it. And that's where you can output some kind of command and in order to turn the LED on, depending on what code we write for the Arduino. And to complete the circuit, we'll want to ground the circuit itself. So we'll click on this pin that's in the same row as the LED itself, bring it out, and go up. And then we'll connect it to the ground pin right here. We'll actually change this to black so it's ground. And then we'll change this to red. So there you have it. That's your circuit. And if we actually start the simulation, because we didn't write any code for the LED yet, it's not going to turn on because the pin 12 itself isn't running any command yet. So we'll stop that. And now we can move over to code. That's going to be this button right here. And the cool thing about coding in Tinkercad is that you can actually code either using blocks, so you just use drag and drop for if you don't know how to code, or you can actually use text. And we'll just continue. So text, this is the code that is actually going to be sent to the Arduino itself. And this text is like the language that Arduino uses in order to execute code. And by default, in Arduino, there are two chunks of code. And these chunks of code are actually called functions. And with functions, in code, it helps break down your entire program into small sections so that you could easily go back to whenever you need to in your code, like referring to or just separating it by sections. And so with these two functions, you can actually name them based on what the function of the code itself is. So you can see this first function is called setup. And with setup, this chunk of code only runs one time. And with this code, it's actually initializing your code or your pin to, so see pin mode 13. So it's actually turning pin 13 on, and it'll either input or output something. So in this case, it's outputting something, which means whenever we run this code, pin 13 is actually going to be sending something outwards. And if we were to do input, that means pin 13 is taking in some kind of value. But for this example, we'll just stick with using output for pins. And in this next function is your void loop. And loop means that this section of code is going to run forever and it's never going to stop. So it'll run all these lines from line 8 to 11, and then it'll go back to the very beginning again. And we'll actually run this code first because it's actually the default code that comes with, that Tinkercad leaves as default for whenever you first start up your circuit. So we'll start the simulation. And so pin 13 is actually connected to this LED right here. And so you can see that when it first set up, it's initializing the LED to output something. And so in this case, pin 13. And then it'll start this void loop code. And what's happening with digital write is that we're telling pin 13 to be high. And so high means this code is telling the Arduino board to output the most power or all the power from the board to turn this LED on. And then this next line 9 is your delay. And so the delay is to help the code run better instead of, because if we didn't have this delay line, it'll go from high to low really fast. But that might cause some problems. So we have a delay in between turning the LED high and low so that there's a chance for the code to pause before moving on to the next line. So line 8 is telling the LED to turn on. Then line 9 will tell the Arduino to wait 1,000 milliseconds, which is the milliseconds is the unit that, or time unit that Arduino runs on, and 1,000 milliseconds is just 1 second. And if you're whenever you're writing your own code, you can actually just convert from seconds to milliseconds by multiplying the number of seconds you want by 1,000. And then you can input that in here. And line 10 is digital write, pin 13 low. And so now we're telling the LED to, we're telling the Arduino to kind of turn off pin 13. So that's why the LED turns off at that. So we'll wait 1,000 milliseconds before going back to high again. So this chunk of code right here is just an endless loop of turning the LED on and off. And so that's the LED that's on the Arduino by default, but we actually want to power this LED that we added right here. So we'll move it over so you can see the code and the circuit. Okay, and now we'll go back to the code. And now we're going to change some of these things. So because we have the LED plugged in, this external LED plugged into pin 12, we're going to want to change the pin to pin 12 so that it will activate pin 12 and so that we can get some kind of high and low out to this LED instead.
Hey, Lan.
So, yes.
Sorry to interrupt you. On your screen, can you try double clicking on your screen share window to see if we can maximize that? I think we might be having some issues with that.
My screen share window.
In the hop-in window, yes.
Okay.
Yeah. So just go ahead and double click on the screen that you're sharing as in the window. And is it maximized for you?
Yeah, so I see my the Tinkercad screen and then my webcam and your webcam right below it.
Right, okay. Just making sure. Okay, sorry, continue.
Yeah, is everybody else able to see it okay, or in the audience? Because I think it, the audience would have to double click it or full screen. Okay.
It looks like it's working, so I think we're good now. All right, thank you for that. Sorry, please continue.
Okay. Let me, yeah. Okay, so now we're going back to changing the pin numbers. So we'll just change these two. So now we're able to send out some kind of value from this Arduino board to pin 12 so that we can turn this LED on. So we'll start the simulation. So now you can see that the LED is flashing. So earlier we saw it on here on the built-in LED, but that's when it was wired to pin 13. But now that we activate pin 12, we're able to take advantage of that pin and send it to the external circuit that we built to control the LED itself. So now it'll turn on for 1 second and then turn off for 1 second. And one other thing that you can actually do during the simulation is changing the resistor value. So there's actually something called Ohm's law, which is an equation that relates the voltage to the product of the current and resistance. So you can actually look up Ohm's law if you're interested in learning the theory behind circuits. and can actually change the resistor values to any value that you want. And so that will also change the color of your resistor. But as you can see, when you're flashing it, when this LED is flashing, there's like a exclamation point. So that means that there's some kind of error. So let me go back to the code for a bit and comment this out. And so with your code, you can actually, these two slashes are your comments. So whenever you're running the code, it won't run these two lines. And so we just want to, we'll comment that out for now so that we can see what the error is for. And so when we hover over it, you can see that the current through the LED is 52.6 milliamps. But the LED can actually only take 20 milliamps through it. And so if you were to actually build this circuit with hardware, you're actually going to burn the LED itself out, so it won't be usable anymore because you're allowing too much current to flow through. Because your resistor is actually supposed to limit the amount of current that goes through, and which is why we have this resistor in the first place. So when you're using LEDs, typically a value of 100 100 ohms should be good enough for the LED. And like we said, the resistor actually limits the current flow. So if you were to increase the amount of, if you were to increase the resistance value, it'll actually make the LED dimmer because you're letting less current flow through. So in this case, but we want to actually see the LED, so we'll just leave it at 100 ohms for now. Okay, so stop simulation and go back to the code. So this is the text code that we have. And if you were to build the actual circuit, the cool thing about this Tinkercad is that you can actually download the code and you'll get a file that you can run in the Arduino environment. And you can actually export whatever code you make in here to your physical Arduino board. And we'll go back to the block text for a bit. Yeah, so when you're editing these block text, you actually can't edit, or when you're editing the blocks, you actually can't edit the text at the same time, because that's, I guess, one of the downsides of using Tinkercad and trying to, if you want it to code like an actual programmer. But if you don't know how to code, that's perfectly fine. You can still use the default blocks that are available to you and have the code pop up over here. So I'll actually get rid of all these blocks. Yeah. So now you can see that your text code is actually empty. And we'll want to still use the external LED. So what we're going to do is drag out this output block. And we want to set the pin to pin 12 because that's the LED that we want to use. And so now you can see over here, it added 2 lines of code for us. So it's what we had earlier, pin 12 outputting something, and pin 12 being this way, that's high. Then to add the delay, we'll go over to the control and add this control block for delay time. And you can toggle between seconds and milliseconds. So like we said I mentioned earlier, the units that the Arduino text code runs in is milliseconds. So over here, you'll see that it's, if we leave 1 millisecond here, it'll be 1 millisecond in the code itself. But let's leave it at 1 second. And it'll do the conversions for you. So it'll translate 1 second in the block code, will translate to 1 1000 milliseconds in the text code. And to turn it off, we'll go back and bring out this next output block, change it to pin 12, and we'll turn it off. And then go to control and add our delay. So it's basically the same thing that we just did previously in the text code, but you could do the same thing in your block code, and it should still run the same way. Yeah. So now we have our blinking LED. And so now you guys are able to code and build a circuit with a flashing LED using either block code or text code. And so that's a really simple thing that you can do in Tinkercad, but you can actually do a lot more than just that. Some projects that I have that you can also find on the internet, like YouTube, some people do control the LED using potentiometers. So that's where you can change the brightness of the LED by dimming it or making it brighter. Or you can even use other components like a photoresistor. So with a photoresistor, you can change the brightness of the LED depending on the brightness that the photoresistor can sense. So if it's really dark, then the LED will be really dark. But if it's really bright, then the LED will turn on because you're allowing more current to flow through this photoresistor. So both of these potentiometer and photoresistors are like a resistor, but they're variable. And let me stop sharing this tab and I'll open another one. I'll show it just real quickly. Yeah, so this is one of the, wait, this is the same one. Yeah, so this is a circuit with a photoresistor, and you can add some extra components to it. And when we're starting the simulation, you can see that you can adjust the brightness of the LED. Let me see, depending on how dark or what kind of light the photoresistor can sense. And so you see when we leave it on this side, it's really dark, so the LED will turn off, and over here it's really bright, so the LED turns back on. And one more thing, you able to see my potentiometer? No, okay. Oh. Yeah, okay. So this will be the other setup for your potentiometer. And see that the LED is really bright right now. And when we turn it back down, the LED will become dim again. And so those are just some of the things that you can do in Tinkercad with just an LED. But with so many components available to you in Tinkercad, you can pretty much have a lot of creative freedom and do whatever you'd like with either temperature sensors or maybe some motors if you're trying to run some physical components. And then another thing is there's also circuit assembly, Arduino starters. And so you can actually pick out some of these default circuits that are already built for you and do whatever you'd like with it and like kind of experiment and see what works for your project. So, yep. So I know we're at the end of our workshop. Do you guys have any questions for me? I don't know. There might be another workshop people are going to right now. But for whoever's still in the audience right now, if you have any questions about what you could do in Tinkercad or any questions about what I just went through, feel free to message me on Discord or tag me in one of the channels, and I'll be more than happy to help you guys out. So, yeah.
Sounds great, Lan. Thank you so much for that workshop. I definitely learned a lot. That was amazing.
Cool. Glad you could learn something from it.
Like you said, if you have any more questions, feel free to send them in the Discord. But other than that, have fun with the rest of your workshops. Got tons of great stuff planned for y'all.
Yeah, good luck on everyone's project. Hope you guys can create something cool with it. So, yeah. Okay. All right. Bye, guys.
Bye, y'all.